given the graph of f below, is there an x value in the interval from 1 to 4, looking for an x value, such that f of c equals 2. Okay, c, what's c? Well, obviously, based on its placement, it's an x value. So what I'm looking for is there an x value that if I were to plug in that x value, special x value, we'll call it a c, I would get an output of 2. Okay, output of 2 means a y value of 2. So up here at 2, there we go, we come over, and there, yes. And the answer is 3. They didn't say what is it. They said, does 1 exist? Yes, 1 exists. Man, this is easy. I love this stuff. Okay, given the graph of g of x below, and we've done this twice, is there an x value in the interval from 1 to 4 such that g of c equals 2? Same question. So I don't see what happens behind this little curtain. What's going on behind the curtain? I don't know. It's hidden. So the question is, am I guaranteed to have an output of 2? So let's go back up here. Output of 2, yes, okay. Output of 2, okay. Don't assume that this graph is this graph. They look a lot alike on the ends that you can see, but they're not the same. I did 2 graphs, by the way. You'll see why in a minute. So maybe my graph does look exactly the same. Maybe so. So in that case, the answer would be yes. Maybe my graph doesn't look the same. Maybe my graph is a straight line. If my graph was a straight line, then the answer would still be yes, but it would be in a different place. It'd be a different x value. But maybe my graph looks like this. I'm going to go a little crazy on you here. Maybe it's piecewise. They didn't say otherwise, right? So maybe we have a continuous graph and maybe we don't. Maybe we don't. So given the graph, am I guaranteed to have an x value in the interval from 1 to 4 such that my output is 2? Maybe so. Or maybe not. So, no. Okay, switching back to the function f, not this one, it's this one. Notice the difference. Notice that this one looks like it has the same beginning but a different ending, okay? So let's see what we can do with this one. I don't know where my pencil just went. I just had it, and oh, there it is. It blended in with my ink pens. Given the graph of f below, is there an x value in the interval from 1 to 4, looking for an x value here, such that I am going to have an output of 3. So here's 3. I'm wondering if this graph ever reaches 3. Well, I don't know what happens behind this little shaded part. That's the veiled portion. So maybe not. Maybe... Whoops, maybe I'll break the pencil lead. Maybe so. Maybe we have a couple points. Maybe we have a situation, I'm going to come back over to this one, where we don't even have a continuous function, and we have some little thing that it might even stop like there. Do this sort of thing, and that would be a no. We have no idea why. I mean, we have no idea what it would look like, so we're going to have to go with a no. So here's the situation that we have explained so far. Yes, we could guarantee that there is an x value with a specific output only when we saw some continuity. We can't always guarantee the continuity, right? And we also saw that the outputs, and check this out, the outputs from 1 to 4. Here's the output at 1. Watch where I'm pointing. Here's the output at 1. Here's the output at 4. That in between those two values, we had an output of 2. Okay? Here's the output of 1. Here's the output of 4. Oh, 2 is in between them. Not necessarily exactly in the middle, but it's in between them. So I needed a couple things. I needed to know that the function was continuous, first of all. And I also need to know that even if we had a situation like I had originally drawn here, you don't have to keep drawing and erasing and all that stuff, but if I had a situation like I drew right here and we just connect those 2 points and it looks all nice and neat and wave-like, if I was to have that, then my output at 1 and my output at 4 are here and here, and I'm not guaranteed to have an output of 3. Okay? So the intermediate value theorem is an existence theorem. Intermediate means in between, not necessarily exactly in the middle, meaning that if a few conditions are met, we can state that something exists. I may or may not be able to find exactly where it is, but I could at least say, hey, it exists. This is really common sense when you think about it, but we're going to put it in mathematical terms just to confuse you. Okay, switching colors. If f of x is continuous on the closed interval, we have to have continuity, and k is any number between f of a and f of b. Stop right there. For any existence theorem, an existence theorem is when I say, hey, I know something exists because I met a couple conditions. Here's condition number 1. Any existence theorem is going to have conditions. There's existence prerequisite number 1, and here's prerequisite number 2. There are 2 things that you need, and here is the result. If I know the function is continuous, and whatever y value I'm looking for, and I think that's worth noting, this is a y value, is between the 2 y values defined by the interval, then there is at least one number c in the interval from a to b. Okay, let's pause for a second. C is going to be an x value. How do you know? You'll see it in its context in a minute. So C is an x value and K is a y value. There's going to be at least some x value in AB, in the interval from A to B, such that when I plug in that C value into the function, I will get the K value that I wanted. Okay, quick graph, super quick graph, and I'm going to try to squeeze it here in the corner. I wrote way too big. So if I have a graph that goes from A to B, and my graph is continuous, and there is some y value in between my 2 inputs, then I'm going to have some other stuff that happens. Here, watch this. So I'm going to draw, there we go. I don't know why I always draw an increasing graph, but we're going to. So this point right over here, when I plug in an A, I get f of A. When I plug in a B, I get f of B. And if there is some K value in between my 2 inputs, and I have continuity, then I can guarantee you, absolutely guarantee you, that there's at least one input that'll give me that desired output, and we'll call it C. It is common sense when you put it in a different context. Okay, let's talk about this briefly. Years ago, I heard that you don't have anything to look at while I'm talking here. Years ago, I heard that if you have the root of a sweet onion, and I used to put sweet onions in my scrambled eggs in the morning, it's great. You have the root of a sweet onion, and you throw it in water, put it in sunlight, it'll regrow, and it's true. So I would take the root of the sweet onion, and it would be, let's say, about 1 inch long. And I put it in water, and I actually left on a trip one time. I was gone for like a week over the summer. I threw that root in there. And I came back. Let me rephrase this. I've done this wrong. I didn't need to put the 1 there. Let's change this up. 0 time has elapsed. I came back 7 days later. At 0 time, the root was 1 inch long. I came back and it was about 8 inches long. I'm making the numbers up, but just bear with me. I have no idea what the graph looks like in between here and here. But I know at some point during the week when I was away that at some daily value. Maybe it was day 3. Maybe it was day C. I don't know. But at some point, the length of that green onion was 5 inches. At some point. At least one value. Well, it was going to be exactly one value based on what we know about the growth of plants. But the function has to be continuous because I have no idea what it looks like. But this green onion is going to have these 2 dots connected. I observed it here, and we're not going to have a piecewise function. Plants don't do that, okay? So it's going to be something. It might be a little curvy, might be different. I have no idea. But there is at least, and there is exactly in this case, one value, one time value at which the length of that green onion was exactly 5 inches long. Don't know what it is. We'll call it C. It's really common sense when you think about it. Then we put it in mathematical language just to confuse you.